We're doing mind action. We're on exercise 9. We're doing number E. Nice question. And as we work towards our revision exercises, I'd like you guys to also just pop me messages if you get stuck with any through the course of the week before our next meeting. Right, let's quickly put number 9E into the board. Okay, I've got a triangle. It looks something like this. Right, and the name of the triangle is P, the big one, Q, R, and then I have a letter D here. I hope I'm on the right one. E, okay. Then a Y of 5 centimeters, 4 centimeters, X, 10 centimeters, and 3 centimeters. Great. Okay. So if we look at our triangle here, the question that's been asked is to calculate the value of X and Y in each case. The following pairs of triangles are similar. Okay, so we know that we've got similar triangles. With similar triangles, we are allowed with similar triangles to focus on the angles that are the same. So I'm just going to quickly run through the fact that exercise 9 starts by stating that the following pairs of triangles are similar. What does this mean to us? Similarity, we learned, is if triangles are similar to each other by sharing the same angles. So the angles are the same. Okay, great. Now, what I'm going to do now is I'm actually going to prove it with this triangle that's been given here, just to run through that, because that's basically the exercises we did last week. But how would you have proven this if they were to ask you from the beginning, just solve for X and Y, without making the statement to prove similarity? So I'm just going to run through it by stating in triangle PQR, my big one, PQR. Here's my big triangle first, PQR, and in triangle PDE, PDE, that's my little one, okay? So what I want to do is I want to just run through how exactly do I prove that they are similar so that I can solve for X and Y. So I'm going to make the little one yellow. There's PDE. Great. Now I've added parallel lines here because we need something else in order to prove that these are in fact similar triangles. But what I do see here is a shared angle, which remember we said watch out for those. That's really common in similarity. So I'm going to jot down my 3 points in order to prove it. Very much the same with our congruency, but remember congruency has scenarios. Similarity, we only look at angles that are the same. So let's start with angle P. Angle P is equal to angle P. How can I make that statement? It is a common angle. It's a shared angle. Right, what's the next one? Let me just write a little bit neater here. What's my next one? I've got parallel lines which help me to find corresponding angles. So let's go straight to, in my big triangle, I've got angle PQR equal to, in my small triangle, because I must state, firstly, my small triangle is the second triangle, my bigger triangle is the first one. Everything in my first triangle is equal to, then follows everything in my small triangle. So PQR is equal to angle PDE. Why is that the case? Right, corresponding angles, but we must add something here. NB, we must not forget to state which lines are in fact parallel to make that statement, because corresponding angles will not exist if they weren't parallel lines. Therefore, because DE is parallel to QR, so I've added that in for the sake of the proof. And then thirdly, I will make the statement, great, that angle E is equal to angle R. Or you can go straight to third angle would be the same because of the sum of the interior angles of a triangle. That is also correct. So P or Q, angle P or Q is equal to angle PED. And that's also corresponding. And it's also because DE is parallel to QR. You will not get your marks if you don't add the parallel lines to corresponding alternate or co-interior. Alternatively, your third angle could have been the result of the sum of the interior angles of a triangle, because if you know that these two are in fact the same, obviously the third one must be the same measure. Now, let's make that beautiful statement that's going to help us solve X and Y. Therefore, triangle PQR is similar to triangle. Now, let me go and see. Okay, P is equal to P. Q is equal to D. And R is equal to E. So there's the correct order. Right. And now, what's that reason right there? That reason would be angle, 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 because that's the only reason that we use. Angles are the same in similar triangles. Now, what's the purpose of this exercise? The purpose is for us to find the missing lengths. The missing length X, and I see a missing length Y. Right, which means now I can actually, after proving similarity, that's the whole reason why we've done this. We have proven similarity. Therefore, we're going to use our little rhyme, smiles and eyebrows. There we go. I promise you, if you're going to remember smiles and eyebrows, it's going to help you set up your proportionality so that you can solve. So that's your little link. As soon as you see you have to solve a side, you think to yourself, smiles and eyebrows. It's like the best little link ever. Great. I'm going to highlight them quickly. So my smile is PR. Make the sticker PR over this smile is PE. Okay, my next one, eyebrows, PQ over PD equals, next one, QR, the other eyebrow, QR over DE. Here's my smile and eyebrows. Right, which means let's go ahead. What does that all mean? Okay, what exactly is PR? PR is a length. PE is a length. PQ is a length. PD is a length. These are all lengths. Why could I make that statement? I could make that statement because triangles are similar. I've just proven it. But also, in exercise 9, it starts off with a statement that triangles are similar. So you didn't have to do all this proof. I only added it for the sake of clarity so that we can remember how do we actually prove it. Now let's go back to our diagram and see. Okay, great. I want to quickly find all those lengths. So I'm going to transfer PR over PE is equal to PQ over PD is equal to QR over DE just to the side because we're going to solve. Let's find PR, color code. PR Where's PR? PR is here. It's this length here. So it's the length of Y, PE, plus the length of ER, which is 3. So let's just write it like that. PR is equal to Y plus 3 centimeters over. Okay, don't stress, just substitute. PE, where's PE? Okay, so PE is on this side, PE, that's just Y. Okay, right, so let me just write Y is equal to, let me just fill in everything, get all my information, see what I have. PQ, okay, great. PQ is here, that long length. PQ is 4 centimeters plus X. I'm just setting up my lengths. And what's PD? PD is this 4 centimeters here. Okay, great. I'm not going to go any further with that. I'm just going to go one step further with my proportionality that I've set up here. Sides are in proportion because they will give me a constant. And that one is going to be my intermediate length. So just continue with equating. Now let's find QR. QR is 10 centimeters. Let me just separate that. Okay, and what is DE? Okay, DE is 5 centimeters. Right, there we go. We have a constant. Why am I focused on my constant? It's because the one that is constant will help me solve the others. So if I then have said, let's look at something that we call the commutative law. If A is equal to B is equal to C, actually, sorry, it's the transitive law. Then I can say that A is equal to C, that B is equal to C, that C is equal to A, whichever way, right? So if I say that this one is equal to that one, then it's actually also equal to that one. So in each scenario, you have enough information. So let's just take our Y plus 3. Let's take this part of our equation and we just add it on this side and we directly equate it to the constant in our equation because this is all part of the same equation. That's what makes this true. It's all part of the same equation. So I am allowed to go and equate it to each other right there. Great, I've got it right there. Then let me take this part. Like I said, if A is equal to B and B is equal to C, then A is equal to C and vice versa. That's the beauty of maths. So when we go ahead like this now, we can see, okay, great. Now let me focus on X, maybe just because I want to solve X first. Doesn't matter, you can go to Y first as well. And then you can do the next lot here with our next part. But both will have the same result in terms of equal to 10 over 5. Great, so let me carry on here. Let me do this one first. Okay, so if 4 plus x is equal to 10 over 5. What's 10 over 5? But let's keep this 4 over here. 10 over 5 is 10 divided by 5. So you could just call it 2. I like to call it 2 over 1 to help you guys see how cross products will help us cancel out things now. So we are allowed to do this yet again. Together with equations, we have all these wonderful tricks that we can perform. A divided by B is equal to C divided by D. Therefore, A times D is equal to B times C. This is all true because of one term equal to the other. Right, and then we can then say, okay, 1 times anything just stays 1. So that's going to be 4 plus x is equal to 4 times 2 will be 8, which now allows me to continue. And what I do on this side is I want to get rid of the 4. So what I do on my left-hand side, I have to do on my right-hand side. Solving equations come in, and 8 minus 4 leaves me with 4 centimeters. Let's go have a look. Does that look like it's okay? Does it look like it makes sense? Then we basically see, okay, great. If that's 4, and that's 4, then that gives me a total of 8. Okay, cool. That looks around, yeah, because that bottom part, QR, was 10. So let's carry on with the top one with Y. And then we see, okay, great. So I do the same. I can simplify 10 centimeters over 5 and go directly to Y plus 3 centimeters is equal to, over Y, is equal to 2. 2 over 1. Great. Let's take it one step further. We do our cross products. And we see that Y plus 3 is going to be equal to 2Y. Slightly different here, but let's take it further. Now I have my 2y there. We don't have to work with y on the left-hand side. You don't have to work with y on the right-hand side, but I like to work with it on my left-hand side because at the end of the day, y is going to be equal to something. So this gives me minus 2y plus y is equal to a minus 3, carrying it over, which leaves me with a minus y is equal to minus 3, which gives me a positive y is then 3 centimeters, okay? So, what do we see? We see that in our big picture here, that x would be 4, y would be 3, which makes PQ 8 and PR 6, which shows us that relationship that exists right here. I have doubled, therefore I have doubled, therefore I have doubled.